year ago, these cops and lawyers wouldn't dare cross any of you. I mean, what happened?
So what are you proposing?
It's simple. Kill the Batman.
Hi, my name is Bryan Chong Lianq, FIN 1704467 from Xiamen University, Malaysia. In this video, we are going to discuss about the film The Dark Knight.
Here's my card.
The film The Dark Knight is directed, co-produced and co-written by the legendary film director Christopher Nolan. Christopher is well known for his cerebral, non-linear, and storytelling filming style. Some of Christopher's masterpieces are Interstellar, Inception, and Dunkirk. Within a year after the events of Batman Begins, Batman, Lieutenant James Gordon, and new District Attorney Harvey Dent successfully begin to round up the criminals that plague Gotham City until a mysterious and sadistic criminal mastermind known only as the Joker appears in Gotham, creating a new wave of chaos. Batman's struggle against the Joker becomes deeply personal, forcing him to confront everything he believes and improve his technology to stop him. As Batman and the Joker fights for the soul for Gotham, Batman has since realized his moral code of no killing is his greatest weakness. In this report, we look at some of the stunts performed in the movie, determine whether it is realistic or not. Furthermore, we look at some psychology aspect, the game theory used by Joker, and how the role of Joker made this film so interesting to watch.
That's funny, it didn't dial out to 911. It was trying to reach a private number.
Is it a problem?
No, I'm done here.
Mob bank. I guess the Joker's as crazy as they say. Where's the alarm guy?
Boss told me when the guy was done, I should take him out. One less share, right?
Funny, he told me something similar.
No!
That's a lot of money. If this Joker guy was so smart, he'd have had us bring a bigger car. I'm betting the Joker told you to kill me as soon as we loaded the cash.
No. I killed the bus driver.
Bus driver? What bus driver?
School's out. Time to go. Guy's not getting up, is he? That's a lot of money. What happened to the rest of the guys?
In this analysis, we take in a new perspective by looking at the clever use of incentives, asymmetric information, and backward induction. By incentives, we mean that a thing that motivates or encourages someone to do something. Asymmetric information means an individual has more or better information than the others. Backward induction is a technique used to analyze a game where the reasoning is backward in time, from the end to the beginning, with anticipation of what other people will do, then decide their move. In the cutscene just now, we see that the Joker told the bad guys to kill the other when their job is done. They do it because the bad guys knows that if there is one less member, each of them will have more loot after splitting. This extra loot is the incentive for them to kill their bad guy friends. Now, we summarize the whole strategy played by Joker. He effectively eliminated the bad guy that disrupts telecommunication and the bad guy who opened the cash vault by using incentives. Asymmetric information has also been shown here, as no other bad guys knows that they will be killing each other, including the bus driver. Therefore, they thought they are the only one who is assigned to kill. Lastly, Joker used backward induction to counteract the final bad guy's anticipation to his own death. Joker predicted it and used the bus driver to eliminate him.
Tonight, you're all going to be a part of a social experiment. your magic of diesel fuel and ammonium nitrate, I'm ready right now to blow you all sky high.
Liberty come in, over. It's dead.
Anyone attempts to get off their boat, you all die.
I'm zeroing in.
Each of you has a remote to blow up the other boat. At midnight, I blow you all up. If, however, one of you presses the button, I'll let that boat live. So, who's it gonna be? Harvey Dent's most wanted scumbag collection, or the sweet and innocent civilians? You choose. Oh, and you might want to decide quickly because the people on the other boat may not be quite so noble.
The Prisoner's Dilemma is one of the classic examples of a game. The Prisoner's Dilemma is one of the classic examples of a game analyzed in game theory. It explains why two completely rational individuals might not cooperate, even if it appears that it is in their best interest to do so. A typical example would be, two criminals are arrested and imprisoned. Each prisoner is in solitary confinement with no means of communicating with each other. The prosecutor only has sufficient evidence to charge them for a lesser charge on their criminal act. Each prisoner are given a chance to either betray by testifying the other committed the crime or to remain silent. If A and B cooperate and remain silent, both of them will be charged for 1 year imprisonment. If A betrays and B remains silent, A will be set free and B will be imprisoned for 3 years, vice versa. If both A and B betray each other, the prosecutor will have more evidence to charge them. They will need to serve 2 years in prison each. We look at the payoff matrix. We can observe that betraying offers a better payoff no matter what the other prisoner choose. 0 to -1 and -2 to -3. Therefore, betraying is the dominant strategy for both of the prisoners. When both of them are rational, self-interested individuals, both of them will choose to betray, and the outcome will be 2 years imprisonment for both of them at the bottom right cell. He concludes that when they are pursuing individual rewards, they thought it's best for them individually, but they did not realize it would be best if they both kept silent. This is the payoff matrix for the ferry scenario in the movie. The grey cell indicates that both ferries trigger the bomb at the same exact moment, which is very unlikely. Therefore, in this analysis, we neglect the grey cell. If A triggers the bomb and B do nothing, B will die and has a payoff of -2, the worst payoff for them. A, however, will get a bad reputation of killing others, therefore with a payoff of -1. This payoff has the assumption of people prefer having an ugly face than losing their lives. For the blue cell, they both would not die if both of them did not trigger the bomb. But they didn't know that because jokers tricked them and they thought they would both die if they did not do anything after a certain period of time. The payoff in the blue cell should be 0, 0. Sad thing is that Joker tricked them and they didn't know what the actual payoff was. So was the Joker right about the soul of Gotham? Does the people of Gotham really have a dark side in them? Would they kill the others to save themselves? Watch the movie to know.
The tally is 140 against 396 for.
So go ahead, do it!
We're still here. And that means they haven't killed us yet either.
this scene, we see 5 SWAT members hanging with a single rope. The physics here is relatively simple. It is just a representation of Newton's third law. That is, for every action, there is a reaction. The weight of the SWAT members pull the rope downwards, and the rope has a tension force pulling them outwards so that the SWAT members can remain at rest. We know that the average mass of a SWAT member with equipment is approximately 113 kg. We know that force equals mass multiplied by acceleration, and the acceleration here is the gravity, which is g. So when we plug in the numbers, we get about 1100 Newton force. An SPIE rope used by military has tensile strength of 106,000 newtons. Therefore, the SPIE rope can easily withstand the tension force. From the scene, we first observe Batman's cape become structured when he extends his arms. This is because his cape is made by a special fabric that can be structured when electric current is applied. Lucius mentioned this in Batman Begins.
It's called memory cloth. Notice anything? Regularly flexible. But put a current through it. Molecules realign, becomes rigid.
What kind of shapes can you make?
Can be tailored to fit any structure based on a rigid skeleton.
Now, we divide the stunts into 2 parts. First, the vertical free fall, and second, the horizontal flight before crashing into the building. When Batman leaps from the building across from Laos, he falls for about 4 seconds before opening his wings. Neglecting air resistance, free falling for 4 seconds and assuming an acceleration due to gravity of 9.8 meters per second square, we can calculate his velocity just before he opens his bat wings. We have v equals to u plus at. After plugging in the numbers, we have a velocity approximately to 40 meters per second before opening the bat wings. Now we enter the second part of the flight. When Batman opens up his wings after the 4 seconds free fall, we can see that when Batman spreads his wings, he moves into a circular path and his motion goes from vertical to mostly horizontal. It is the force of air resistance created by the wings that pushes him into the circle, and therefore it acts as a centripetal force during that part of the motion. To hold his arms out without buckling, Batman has to exert the same force back on the air, as stated by Newton's third law of motion. So while he moves in his circular trajectory, we can calculate the force that will be exerted on Batman's arms. From the scene, we estimate that Batman moves into a circle of radius 20 meters or so, and that he has a mass of 86 kilograms. If his speed remains relatively constant as his direction changes, we can approximate the force acting on Batman's arms as he sweeps through the bottom of the arc. By using the equation F equals mg plus mv squared divided by r, after plugging in the numbers, we have about 7,740 newtons of force. Batman has to hold approximately 7,740 newtons of force, which is about 800 kg in force, with both of his arms to make the glide. Just imagine doing a bench press with 400 kilograms of dumbbell each side. The current bench press record of 335 kilograms total is set by Kirill Seryshev in 2015. Batman will need to be able to push out at least 2 times of what Seryshev has to make the flight successful. Of course, if Lucius Fox had invented some sort of structure on Batman's suit to help him withstand the force, Batman could have made it easily.
Now there's a Batman. Oh, you want to play? Come on. Come on. He missed!
You can't stop here. We're like sitting ducks.
We calculate the possibility of using only the 2 cables to stop the semi-truck and eventually flip it. In this calculation, we assume that both ends of the cable intact is perfectly rigid with no chance to break apart. Assume the semi-truck is empty with mass of 11,340 kilograms, traveling at city speed limit of 30 miles per hour, which translates to 13 meters per second, and time taken for semi-truck to be fully stopped is assumed to be 0.1 seconds. We know that acceleration is also rate of change of velocity, therefore we can write the equation F equals to mass multiply velocity minus initial velocity divided by time. After plugging in the numbers, we get about 1,474,000 Newton of force. According to Newton's third law, the cables used by Batman will need to withstand at least 1,474,000 Newtons of tension in order to not snap and break. The highest tensile strength material ever measured is carbon nanotubes of 63 gigapascals, which translates to 6,300,000 Newton per cm square. Despite the high tensile strength, scientists still could not manufacture a cable out of CNT yet. Recent uses of CNT are additives to structural materials only. But he is Batman, so let's assume he has the ability to manufacture such cables with CNT, so this truck flip would be possible. However, even if the CNT made cable exists, the front grille of the truck would just break off with such a huge force acting on it.
Two, one.